Alright, today in our club meeting, we're going to be learning about physics, because we're the physics club. So, if I dropped this on the floor, the force that is applied, well, that would be...
Hey guys! I'm here for the breakfast club!
This is not the breakfast club, it's the physics club!
Oh man, I can't wait to learn more!
We're going to do so much experiments and we're going to have so much fun! Let's go!
Let's get physical, physical. I wanna get physical. Let's get into physical. Let me hear your body talk. Your body talk. Let me hear.
Let's get physical for physics!
We're going to exert force, accelerate, show momentum, and so much fun!
Let's get started!
Woo! Hey Dr. Phil, we're going to show you force by pushing a car down the street.
Because work equals force times distance.
Today I'm going to be showing you an example of force. Force is work times distance. It is a push or a pull on an object. An example of how to use force in a question on a test is how much force is needed to lift a 25-pound weight. Since we don't have all this information, we can't use this equation. So we have to put in a different equation, which is force equals mass times gravity. So to plug this in, we first need to convert pounds to kilograms. And by doing that, we use dimensional analysis. And it turns out to be 11 kilograms. So then we multiply that by 10 meters per second, which is the gravitational pull. This then gives us our force through calculations, which is 110 newtons.
This is an example of momentum.
Harry is going to apply a force on Brennan to demonstrate momentum.
Yes!
Example of force, and we are pulling a person up a hill.
Makes me that much stronger. Makes me work a little bit harder. Makes me that much wiser. Thanks for making me fight.
Now I'm going to explain an example of work. Work is the transfer of energy. The equation for work is force times distance. An example that would show up on a test and a quiz is how much work do you do when lifting a 25-pound weight in a distance of 1.5 meters? And the force is 110 newtons. So since we're mostly given all the information we need to plug into the equation, all we have to do is just plug 110 newtons and 1.5 meters into force times distance, since that's what we're given. So once we do that, we get 165 newtons per meter, which is the answer.
In this video, we're going to demonstrate conservation of energy because when I kick the ball, the energy from my foot goes into the ball, and when the ball hits the floor, the energy is then transferred into the floor. The conservation of energy says that energy is neither created or destroyed.
In this video, Carrie and Annie will be showing us inelastic collisions and elastic collisions. The first one that they will be showing us is an inelastic collision. The next collision is an elastic collision. Now we're going to learn about inelastic collisions and elastic collisions. In an elastic collision, the cards so-called stick together. This is due to the Velcro that is attached to both sides of them. When headed towards each other, they hit each other at contact and just stick together and don't move when done correctly. In elastic collisions, they retract. when two carts, both cart A and B, head towards each other, they retract and head in both the directions they came in.